we're going to talk about something called complex fractions today, okay? And this is what I want you guys to remember, all right? Writing a fraction, okay, is basically the same as writing a division problem. All right? Which, so if you see 4 divided by 2, well, 4 over 2, I mean, it's the same as saying 4 divided by 2, right? And we also know that dividing and multiplying are very closely related when we talk about fractions. Bless you. Okay? For example, dividing by 2 is the same as multiplying by what? Yeah, it's the same as multiplying by 1/2, right? Because you have to flip. You're multiplying by the reciprocal of your second number fraction, right? And so how are these numbers related? It's the reciprocal, right? Okay. Going from a 2 to a 1/2, well, that is the reciprocal. All right, any questions so far? All right, so a complex fraction, basically, is a fraction divided by a fraction. Okay? And so here's the thing with complex fractions. They actually look very scary. They look a little bit intimidating, but they're really not that bad. All right? You just have to change the fraction into a division, and then you know what to do, because we've actually learned dividing fractions. So step 1. Here's what you do. If needed, you need to add, subtract, or simplify the numerator and or the denominator, okay? Don't try to tackle the big picture all at once. Take it in pieces. Figure out the numerator, figure out the denominator. And then you're going to write it going sideways. So writing it horizontally. All right? You're going to say numerator divided by the denominator. Actually, you're going to write it out the long way. Oh, so they use keep, change, flip. And you know what? We've actually talked about this. You can cross that out. We talked about this as S times F, right? Same times flip. Anytime we see a division sign, we change it to same times flipped, right? You keep your first fraction the same. You change it to a times, change the division sign to a times, and then you flip the second fraction. Okay? And that's basically the same as multiplying by the reciprocal. All right? And then after you do that, well, you just follow the steps for multiplying. Multiplying fractions, okay? And be sure to factor. All right, and then remember, to multiply fractions, we multiply. All right, so we'll skip that last one. right, so let's go to our examples. It's okay, you don't need that last one. It's just... All right, it says simplify each complex fraction. Okay, so guys, when we do complex fractions, this is what I want you to do. When you see this division sign for the big problem, I want you to just make it a little bit longer. All right, then that way it kind of separates your fraction at the top and your fraction on the bottom in the numerator and the denominator. And then we're actually going to rewrite this horizontally. So on top, I have 3 over 14 divided by 24 over 7. Okay, go on. But when you have a division problem, you're not really dividing. What are you doing? Yeah, same times flipped. You're keeping the first one the same, so 3 over 14. And you're changing your division to a times. And then what do you do with the second fraction? You flip it. Yeah, 7 over 24 now. Okay? So here you could cross simplify or just multiply the numerator, multiply your denominator, and then divide. Okay? Yeah.
So you don't have to do
The 1 and 8, and you don't have to do all that.
you don't have to also do
No, because you're not adding or subtracting anything. Okay. So what do you get? What? Okay, and then simplify that. Yeah, you should have 116. Alright, so you can multiply everything straight across and then simplify, or, 3, 24 is 8, 7, 14 is 2, so 1 over 16. Right? Another way to do it. Alright, so try number 2. Yeah, no, try number 2. What's your question? Oh, you're not adding, you're multiplying. Try number 2, please. Remember to draw that fraction line a little bit longer. Alright, so then this turns into 2/7 divided by 18/6, which is really
1 over 3.
same times split. So it should be 2/7 times 6 over 18. And then what is your final answer?
114.
2 over 21. 6, 9, 1, and a 2, 3. Yep. What'd you get? Multiply?
I figured it out.
Alright, so let's look at number 3. So number 3, okay, now we're starting to get more than one term. Remember, draw your fraction line just a little bit longer. Okay? And then rewrite it. Well, here's the thing though. Look at your numerator. Can you simplify there?
Oh, yeah.
Okay, to what? You said, oh yeah. To what?
Oh, yeah. I don't know. I did know, but then I heard something over there.
So, 2 over, what's 2 plus 3? 5.
Oh, yeah, that's what I thought.
And 4 over, what's 5 plus 6?
11. Yeah, that's what that was.
Okay, alright. So now we have to write it out. So 2/5 divided by 4/11. And then remember, when you have divide, you need to change it. This is really same times split. So then this is 2/5 times 11/4,
And then you can make the 2 and the
which
4
gives me what?
11 over 10.
Yeah, 11 over 10. All right, so you guys try the next one, please. Yeah? All right. Just remember you need to draw that line just a little bit longer. It will help. So this becomes 2 over x divided by x over 3, which is really same times flip 2 over x times 3 over x. Can anything cross out?
I did something.
So that's 6 over what? X squared. Alright?
Hold on.
Guys! We're not even at the hard part yet. Like, this is the easy stuff. We gotta move on. Alright. Okay, let's look at number 5. So, number 5. Six over x squared. Alright, number 5, you need to draw your line just a little bit longer so you can differentiate between your numerator and your denominator, okay? So, look at your numerator. Can you simplify? Yeah, you need to factor this. So this is really going to turn into, and we've done a lot of factoring, x plus 2, x minus 2, over x minus 1 times x minus 1. All over x plus 2 over x minus 1. Right? Just copying the whole problem over, but I still need to simplify my numerator. So my numerator, what can I cancel out? Anything? No. Okay. Well then, now I need to take this, move it down here, okay? I'm going to write it out the long way. So up on top, in my numerator, I have x plus 2 times x minus 2 over x minus 1 times x minus 1. Divided by x plus 2 over x minus 1. Yeah? But when we divide, we're not really dividing. What are we doing? Same times flip. So change it. Well, the first one doesn't change. Just copying a whole lot of stuff over and over. The division sign changes to a times, and then you only flip the second one, yeah. X minus 1 goes on top, and x plus 2 goes on the bottom. What cancels out?
X plus 2 and 1 of the x minus 1.
Okay, good. And only one of the x minus 1. All right. So then, what's left over? X minus 2 over x minus 1. Good. That's it. All right. So this one wasn't too bad because it was just, you just had to simplify your numerator. All right. Let's look at the next one. So this one is going to take a little bit more work, okay?
This one, that's when you get the denominators.
So I'm going to draw my fraction line just a little bit longer, okay? And you know, just in the past when I've done this, right? It does make it a little bit easier for me if I write it out the long way first, and then I get my answers for each, like a simplified form, and then I flip it, okay? So, I mean, if I take this first part here, 1/4 plus 1/3 divided by 1 minus 1/8. See that? You see how I just wrote it out the long way?
What would tell you to skip what you usually do and just write up more? Or what about that problem?
So I'm not skipping it. I'm just doing this so that I can save myself the space and keep it organized. Do you know what I mean? Like you could go the way that we did before and just add this up and then subtract this and then do the same time split. Do you know what I mean?
Yeah.
But if I do it like this and I just have it written out, I can just do my work right underneath.
Okay.
It's just a preference of how you want to organize your work. Yeah.
Which one would you switch? Or would you switch over?
Okay, so don't switch yet. We need to add and subtract first. Okay? We're not doing same time split yet because we need to add those fractions and we need to subtract those fractions. Okay? So leave it as a division for now. Let's add. So here, this one. Okay, you need to find the LCD. Yep, fraction 1 is 4, fraction 2 is 3. Well, 4 is really 2 and 2, right? So yes, 3 times 2 times 2 equals 12. Okay?
Can you also, because, can you also just multiply the denominators and then get your LCD?
Sometimes.
So you can't always.
Like if you had a 12 and a 24, you can. Because it would be 24. And if you multiply it, you just get a bigger. Like it wouldn't be the least. It would be the, you know. Alright, so each of these wants to look like 12. What are they missing? Well, the first one means it's times 3. Whatever you multiply on the bottom, you multiply on the top. Second one needs a times 4. Whatever you multiply on the bottom, you multiply on the top. Yes? 2 times 2 from this 4. I just broke it down. Alright, so we're still doing this numerator, right? Now I have all over 12. 3 times 1 is 3,
Plus 4.
plus 4, which is 7 twelfths. Yeah? So divide, right? Now I need to subtract my denominator. Go to the other bracket now.
Wait, why do you have 2 divided by 4? Why are you dividing both?
I'm just bringing this down. I didn't flip it. You can't flip it yet because you haven't
You haven't
subtracted
divided
this.
3 plus 4 divided by 12. Why? That's the same thing as 7 over 12.
Yeah, so I just wrote it here below it.
What?
Right now we're just simplifying right now.
Yeah. I'm showing the work. I know it's 7 over 12. I know that. But if you don't see that and I just skip that step and I put 7 over 12, I'm not somebody else asking me where I got the 7, right? I got the 7 from 3 plus 4. So, here, I need to find the LCD. Well, this guy is not a fraction, but if I wanted to turn it into a fraction, over 1. 1 and 8, it would be 8, yes. So the LCD is 8 for that one, right? So what is the first one missing to look like 8?
8.
8. Good. Is the second one missing anything?
No.
No. So this is going to be, what is this?
8
All
minus
over
1
8. 8 minus the 1, which is
7 8.
7 8. Yes? So do you guys see what I did? If you have a plus or subtract fractions in your numerator or in your denominator, you need to do those first before you can do same time split. All right? So now that I, added and subtracted, now I can do same time split. So this is 7 twelfths times 8 sevenths. And what is that? 2/3. Yep.
Multiplying fractions, you don't need a same thing.
No.
It's just like addition and subtraction, maybe same thing.
Mm-hmm. Only with adding and subtracting, you need LCD. Okay? Are we okay with this? All right. I realize it's a lot. I mean, you really have to keep your work organized here. All right? Okay, let's try the next one. Okay, so this one.
These are all so big the way they have it. Okay, there we go.
All right. No, this one's not. Up on top, guys, first of all, I need to draw my line just a little bit longer. And up on top, really don't have much going on there. It's just 2 over x plus 2. Yes? Divided by, I have some stuff going on in the denominator. I need to add those fractions. 1 over x plus 2 plus 2 over x. Yes? Okay. Remember, still divide until I take care of the adding and subtracting. So now the numerator is good. I don't have to add, subtract. I can't factor. That one's fine. It's going to wait. Now look at the denominator. You need to find the LCD because it's adding. Yeah? So fraction 1 in the denominator, I have x plus 2. Fraction 2 in the denominator, I have x. Good. Your LCD is x times x plus 2. Any questions about that? Okay. So now, remember, each of these fractions wants to look like the LCD. What is this first one missing? An x. Thank you. Remember, whatever you do on the bottom, you do to the top. What is the second one missing? X plus 2. Okay. So now I'm going to rewrite this very neatly. I'm going to write it a little bit smaller this time. I went a little crazy with my handwriting before. Okay. So this is x times x plus 2 as my LCD. What is x times 1? Is x. Plus, yep, and then I'm just going to distribute here. Seems like you guys are getting it. There we go. Yeah. Yes.
So either
You always, when you add or subtract, yeah, just combine them, and then you're just combine like terms in your numerator. All right, what is x plus 2x plus 4?
What?
2 over x plus 2. Guys, combine like terms.
3x.
3x plus 4 over x times x plus 2. Yes? Okay, so now I need to same time split. But can I factor 3x plus 4? No, there's no GCF. The GCF is 1, right? So this turns into same time split. So the first one is 2 over x plus 2 times, and flip the second one, x times x plus 2 over 3x plus 4. Yes?
Mm-hmm.
What cancels out?
X plus 2.
X plus 2's. And then you have?
2x over 3x plus 4.
Good. Can you cross out those x's?
Nope.
No. Good.
Why not?
Because look at
Because the
3x
addition
plus
sign.
4. That's connecting those, right? All right.
But if it was being multiplied,
Then you could.
okay.
All right. Good job. Next one. All right. So look at the next one. Ready? All right. Okay, this one. All right. So this one, Just looks a little crazy, but you know what? It's the same setup, right? We have a numerator divided by denominator. So draw your fraction line just a little bit longer. And then we're going to rewrite this. So we have a squared. And we know we're going to need fractions, so why not just put an over 1 now, right? Divided by, what do we have down here? 4/5 minus 4 over a. Okay. Do I need to do anything to the numerator? No. The first bracket? No. I need to subtract within my denominator. So LCD is what? Good. Fraction 1, the denominator is 5. Fraction 2, the denominator is a. So your LCD is 5a. What is the first one missing? A. What is the second one missing? 5. Okay. So let's rewrite this. A squared. For a minus 20. Good. Good. So let's give everyone a chance to just kind of. That's good. All right. So here we go. All right. So now, so Dylan was saying, you know, the second one here, the denominator. If you look, this 4a minus 20. Well, you can factor that, right? So this is actually going to turn into 4 times a minus 5 over 5a. I'm just going to rewrite everything because why not? We got to keep everything organized. What? ¿Por qué? Because you got to keep it organized. If I could say it in Spanish, I would say it. Because you have to. No. All right? So now we can do same times flip. Okay? All right, so now we have a squared, well, over 1, times 5a over 4 times a minus 5. I mean, you don't really need the 1, but if you like it, write it. Okay? Now, can anything cancel out? Okay, no. Yeah. So, a squared times 5a, isn't that 5a how many?
Third.
Good. Over 4 times a minus 5. That's it. That's all you can do. Sometimes you do all this, you can't cancel out, which is fine. Okay. All right. Okay, so let's look at number 9. So number 9, we have 2 variables now, but it still follows the same process, okay? So draw your fraction line a little bit longer. In the numerator, we have to add. So 1 over x plus 1 over y divided by, good, x, which is x over 1, right? I'm going to write that in now. Good. So I heard somebody tell me the LCD for this guy. Fraction 1 is x, fraction 2 is y, nothing in common, so your LCD is xy. What is the first one missing? Y. Okay. Second one is missing an x. So we have xy, and then what do we have? Y plus x, right? 1y plus 1x. You can't combine those. They're 2 different terms, right? So divided by x over 1. Now what, guys?
Flip.
Good. Same times flip. You can flip it, but don't forget, now you're multiplying. So the first one is y plus x, or x plus y, over xy, times
1 over x.
1 over x.
And x is
Oh! Question.
Becomes x squared.
Can these x's cancel out?
oh no, they can't.
No,
Addition.
they cannot because this has an addition. Those are actually parentheses.
Bottom 2x is 1x squared.
Good. So then this actually is y plus x over x squared y. That's an interesting problem. That's a pretty problem. All right. Questions about that? Do you guys feel ready to try one on your own?
Yes.
Let me look at the next one actually.
Oh,
No, you've got this.
Brain surgery.
This one, oh, you can do this.
no.
All right, you know what I'll do is I'll even help you out. We'll write it out horizontally together. Right, Jose? ¿Por qué? ¿Por qué? Hmm? Why am I going to do that for you, Jose? ¿Por qué? Because I want you guys to do well. Jose, I'm about to learn Spanish for you, Jose. There we go.
Next class and be like,
I know. All right. So, looks like you're going to have to add the fractions in your numerator and add the fractions in your denominator, but you have
Okay.
ones in your denominator, so this should be okay. 4K. Okay, so while you guys are working, I'm going to do my work up here, and then you guys can compare. If I make a mistake, Jawan, you got to let me know. I may do it on purpose. Jawan! Did you do that because you... So the LCD for your first one in your numerator is just x. So that tells me I have x plus 2 over x. And guys, make sure that you are still paying attention. I know some of you guys, you're like, yeah, I got it. But any of these problems will come up on the test. Okay? And they'll look very similar. All right. Can't factor, can't do anything else. So now I'm going to do s times f, right? X plus 2 over x times 2x over 4x plus 3. How many of you got to this? Good. Good. So now, what can I cross out?
X's.
The x's. That one and that one. I can't cross out anything else, so...
2 parentheses x plus 2 over
All right,
4x
then
plus 3.
find it. 4x plus 3, and there we go. We're done. Good. Okay. So,
First, which one?
okay, let me tell you something about this problem. This problem looks like it might be difficult, and it's not. The reason why it caught me off guard is because it's just going to be a little bit more work.
Make it better.
All right. There we go. Our long fraction bar.
Can't flip it.
It scared me. It scared me. Look at that thing. Okay. So, same thing. Our numerator, it's just a lot. Minus. Divided by. What happened? Are you talking smack about me?
Oh.
All right. So, okay, I have a trinomial finally in my numerator, right? Factor it. You need to find the LCD anyway. Fraction 1 is x plus 5. Fraction 2, you need to factor this guy, and you get x plus 5, x minus 1.
You just look at like trinomials, teach them like automatically figure out like that when they teach us
Because Isaiah, I've been teaching this for a while. No, that's not an O. What's happening?
Okay.
Look at that, I'm trying to instigate stuff. No, it's because if you do the same thing year in, year out, I literally have only taught Algebra 2 since I've been at Herndon. No, I taught other stuff, but Algebra 2 has been the constant. So, anyway, all right, so. Oh, no. Okay, fine.
Oh no.
All right, so I'm going to have to write a little small here. Can you guys see this? Now my GCF is at, oh, no, not GCF. God, I said that last time too. LCD.
They're both like 3-letter like abbreviations.
I know, the worst. All right. Fraction 1 needs an x minus 1. Does the second one need anything?
No.
No. So, I have x minus 1 minus x. Good. I didn't have to distribute the negatives or anything else over there. And then divided by, oh, gotta find the LCD over on this side. Good. LCD equals 5x. That one's missing a 5. This one's missing an x. Whatever you multiply to the bottom, you multiply to the top. Yeah? All right. Yes?
What? Yes.
Yes? Okay. So now, all right, I need to combine like terms right here. And I actually need to do something over here too. What is it? Yes, GCF. Finally, the GCF, right? All right. So this turns into x plus 5 times x minus 1. What is this? X minus x is what? 0. And then minus 1, right? Divided by 2, 5 plus x over 5x. Yes? Yes. All right, so now let's do our same times flip. So the first one stays the same. Times, you flip the second one, so 5x, 2. So, all right, here. So guys, this 5 plus x, right? If I rewrite that, what is it? It's just x plus 5. So, you know, I'm actually going to rewrite this as x plus 5 because I see the same one here. Okay? And then that way,
Everything's like parallel.
yeah, then they're the same and I can say it's squared, right? So, can I cancel anything out? No. All that work for no canceling out, which is fine. 2 x plus 5 squared, x minus 1. And does it matter which order you put these factors in? No, it does not matter. But generally, you know, we like to have, yeah, little singletons up in the front, right? Okay? Questions? Comments? Concerns?
I went to the next one.
You don't want
Okay.
comments?
No comments?
But I have
You don't want my comments?
Okay, I'll slow down. Okay, so guys, let's try this one. All right. I want to show you something that I sometimes see.
Yes.
Here's the thing. Do not do this. Listen to me. Right here, right here. Do not do this, okay? Because you see this x minus 5 and you see this x minus 5 down here, you can guys, if you think, oh, what if I flip the bottom and I can cancel those out? Don't do it, okay?
It's like a temptation.
I know, it is. It's very tempting. but there are no shortcuts here, okay? If it feels like a shortcut, you're doing something wrong. So, okay? You need to add everything on the top, add everything on the bottom, and then do your same times flip, okay? So, let's do this one together. It's a lot.
Oh god, I think I already screwed it up.
Oh no. See, I mean, it's pretty easy to mess these up.
Let me see that.
Careful.
Just gonna see if there's anything.
Oh no, this one is a good one, actually.
Oh wait. Why didn't you set it out with you?
You guys gotta write small for this, okay? Alright, LCD. For this guy, what is it?
X plus minus.
X minus 5 times x plus 3. Okay, what is the first one missing?
X plus 3.
X plus 3. So that means the top one needs to get an x plus 3. What is this one missing?
X plus 5. X minus 5, I'm sorry.
Alright. Okay. So I'm not going to worry about the other one right now. Let's focus on this one first. So we have x minus 5 times x plus 3. Guys, up on top here, you have x plus 3 times x plus 1 plus, got to distribute that guy, plus 2x minus 10.
Okay, so
Yeah.
just so I understand this, you're gonna do the x to the x in the
Yeah.
one first, then you're gonna do the 3 to the
Yeah.
just okay.
Can you cancel here? Or
Nope. You can't cancel here because you still have that plus. You have these two fractions, technically, that you need to combine like terms for. This right here, you need to double distribute. So that will actually turn into x squared plus 4x plus 3. Right? If you boil or double distribute it, right? So sidebar over here, x plus 3 times x plus 1. Distribute x squared plus 1x. Distribute plus 3x plus 3. Yeah, because you have two binomials multiplying each other. Combine like terms, you have x squared plus 4x plus 3.
Then add constant that you put 2x minus 10
Plus 2x minus 10. Okay. And then you combine like terms.
Oh, good lord.
I know. That's where you're at. 4x plus 2x is what? What's 3 minus 10?
7.
All right, good. There, we're finally done with the numerator. Let's go work on the denominator. All right, what? I lost you. Where?
I messed that up.
So, divided by, I'm going to finish up this problem, okay? X plus 3 times x minus 5 is your LCD for your denominator, right? So this one is missing the x minus 5. This one is missing the x plus 3. So we have x minus 5 times x plus 3. You got to distribute everything.
Is it 2x squared plus 2x?
Yeah, all
Or
I'm
minus
doing is
2x.
distributing. Okay? combine like terms.
X to the fourth minus 2x.
And can we divide by 2x?
Yep.
Okay.
Wait, hold up.
Oh, yeah.
Wait. Wait.
No.
Where is, no.
Now, divided by, and I'm actually going to factor that out. No, actually, no, I'll do that. I'll finish this. Listen to it, okay? Make sure you get your homework. So make sure you factor here.
It's your fault we have this. Me? Yeah, you. You just said homework. Look. You said yeah.
Okay, so that is the rest of this problem. Your answer should be x plus 7 over 2x.